Good morning all. I just want to share with you this project I'm doing. It's to build a CNC machine for STEAM NOOR classes. Here is the list of components so far I got. We have bearings, power supply, spindle. This is the motor that actually gonna, this is like a drill bit. And the rods, 12mm rods. There's some 3D printed components like coupler for frame support and for the spindle holder and some other pieces. I'm still working on a lot of pieces that need to be printed, and then I'll share with you the final project and how it's assembled and the code and everything later on. So I'm still working on that. I'm really excited about this project. Screw like this and make sure that the spindle is very tight, just like so. And you take those two rods we cut earlier and we slide them right here between these two bearings like that, and just push. And once this is the other pieces, this is the Z axis. Once the other pieces are attached here, this one is going to move this way, and then we're going to have two rods, one going here, about 600mm, and then the other rod is going to go here. There are going to be two parallel rods here. So once I'm done with the 3D printing the other part, I will put together the entire project. For now, I have the spindle connected to these supports, and then so I have the Z axis as you see. Just have to like that, and then we're gonna put two rods here, one rod on top and one rod here, and the lead screw is gonna go from here. It's gonna be from left to right. That's it for now. Thank you. The diameter of this 3D printed support is made a little bit tighter than the diameter of this bearing. So a little bit of sanding, just like that, it will help. Especially we don't want to glue this. We want actually a tight fit. So that would be a good thing. And then just using a clamp like this one here, you can actually press that inside, just like that, gently, so you don't break your 3D printed material. And that'll do it. Inside this box, you're gonna find an Arduino Uno and a CNC shield, just like that. So basically, these two, they go together like butter and honey. Just make sure you connect them correctly, just like so. Okay, and then you're gonna need 4 drivers. I choose, well, this is the first project, so I'm using A4988 stepper driver. This is the driver I'm going to use to drive my NEMA 17 stepper motor. I might use upgrade it to NEMA 23 if I don't have enough torque of this driver. So I'm gonna play with it a little bit, and if I have to change it, upgrade it, then I would order a new driver. So for now, I choose the cheap way. So go with the small and then upgrade as I need. Okay. So this driver, each driver will drive one stepper motor. So we have 4 drivers, as you see. So basically the X, Y, and Z, and then I'm gonna have on the Y axis 2 motors to help move the load. So this blue terminal here, that's gonna be another driver that is kind of a copy of the one of the Y axis. Okay, so just make sure, I just want to show you how you set up the VRAF for the stepper motor for the A4988. If you flip it this way, you can see there is an enable pin. Make sure this enable pin is lined up. I'm just gonna flip it upside down so you see it. Try to zoom in. Okay, I'm gonna zoom in on this one. For some reason, okay, my camera doesn't wanna, or my hand can't stop shaking. Okay, so anyway, so this is the pin, the enable pin. Make sure that this pin is correctly connected to enable pin on the CNC shield. So there's an EN pin. So, and I have my EN right there. So just make sure that they are lined up nicely. Just like that. Okay. And now once I connected all 4 drivers, including this blue one here, I mean red one, then that's what we have. We have 4 drivers. These drivers are from different company, but the same A49 driver. By the way, reason I'm changing those drivers, I burned them. I didn't set up the VRAF correctly. Now I'm doing it the hard way, so I learned how you have to do it the first time correct. Otherwise, you're gonna burn your driver. But anyway, these are cheap drivers, so it's okay. It's part of the job. Okay. So to set up the VRAF, I found a little formula, and you have to go and look at your. It's like this: VRAF equal Imax times 8 times resistor sensitivity, and from the stepper motor basically specification, my current rating is 1.7 milliamp, and my resistor is it was written 100, and then when I look it up, it's basically 0.1 ohm. So you multiply all these 3. So my VRAF normally is 1.36 volts. But since this is a NEMA 17 and I'm afraid my torque is not going to be strong enough, I normally use 75% of this value, but I think I'm just going to use 90%, and the value we're going to set is 1.22 for the VRAF. Okay, to set up the VRAF, I need to power my 12 volts. Put my 12 volt here for the CNC shield. Then turn my multimeter to DC current, DC voltage, and then I'm gonna use my common. So to turn your VRAF, make sure you put power to your shield, CNC shield. and I'm gonna basically make sure that you have DC voltage in your multimeter selected. And now I'm gonna use those terminals. I'm gonna put the common one on a negative on the ground here, and the positive, there is a potentiometer here, and you can see I have this driver set to 0.87. I have to make it 1.22. This is very sensitive, so the knob that you turn here, you just gotta go slowly. So I did a little bit of tuning. Now I'm 1.04, so I have to add a little bit more. So what I can show you basically, because of my my setup is not helping, I turn this knob just small rotation, and I'll measure. There is a way actually, instead of doing that, you can put you can attach a screwdriver with the alligator clip like that, and then you tune. So that's I think that's a better way. Maybe let's do that. Okay, so let's do this way. I'm gonna attach this, and I'm gonna try to tune as I'm doing the video. So put the negative here, and this screwdriver, see that? I'm at 1 point. So just to check the voltage, I have the DC voltage, as you see, 11.94, so it's almost 12 volts. And I got for the VREF very close to 1.26. I have 1.28. Okay, now is the moment of the truth. After installing a software called GRBL or Gerbil in my laptop, and there is another software that's it's a free software called Universal G-Code platform into my laptop. And after setting all these drivers with the VREF to 1.2, now I'm gonna turn on the spindle. For this spindle, I have a separate power supply, and I'm gonna turn it on. Make sure that everything is working. There is no drill bits connected for safety reason for the first test. Okay, now, so I'm gonna go on try to rehome this one here. Go to action and do return or zero, and notice the z-axis is gonna move up and down to go to 0. I can control the y-axis and the x-axis also, but for some reason the movement is very slow. I'm still trying to fine-tune the movements, but it may be my motor is just. So what I did is it's moving. This lid screw is moving very slowly, and either I'm gonna have to buy a new motors. This is a very small motor, maybe to carry this weight. Upgrade it from a NEMA 17 to NEMA 23. But it works. It seems everything is good. I'm very happy with what happened so far. So I'm good.